Hello again. So excited. Here we go for our second remote learning video. So I hope the first one went well. And if you sent any questions, I will get to them as soon as I can. So we are starting a mix of 9.2 and 9.3. We're going to look at sequences first and just the two different types that we'll be focusing on. And then later we're going to start talking about the series. So right now you can see more than what vocab you'll need for today. So first the one is arithmetic sequence. So we looked at sequences the other day and we looked for patterns. Arithmetic sequences are patterns that add or subtract the same thing each term. So they have a common difference, and the difference is going to be noted by this D here and here. So for a recursive formula, if the sequence is arithmetic, it's always going to have that first term, and you'll just list it. And then you'll always have a of n equals a of n minus 1, the previous term. And then you'll just add the difference on the end. So all you need to know is the common difference, and you can write a recursive formula. Then for explicit, you're going to start with just writing a of n equals, and then you'll plug in for a of 1, and you'll plug in for d, and everything else will stay the same. So again, we just said the common difference, it's the difference between the consecutive terms in an arithmetic sequence. So that is all you need to know for this part of 9.2. And then if we go down here, we also need to know the geometric sequence and how those formulas look. So geometric sequence is when there's a common ratio, so multiplication, between the consecutive. So if I did 1, 2, 4, 8, 16, where I'm multiplying by 2 each time, that would be a geometric sequence. And again, for recursive, you're going to list the first term, and then instead of doing a plus or minus afterwards, you're just going to do times whatever that common ratio is. And then explicit, we're going to put in the first term again, and then the ratio, and then the a of n and n minus 1 just stay there. You don't do anything with them. They're just part of your formula. And then again, we said common ratio. It's the ratio between two consecutive terms in a geometric sequence. So we're going to jump on over to some examples now, and we'll get started on practicing. Okay, so now we have 9.2, 9.3 arithmetic sequences and geometric sequences. So we're going to go ahead and take a look at just a bunch of different sequences and determine if they are arithmetic, geometric, or neither. Excuse me. So remember that we just talked about that arithmetic is when we are adding or subtracting. And then geometric is when we are multiplying. Okay, sorry about that. I realized that the whole screen was not into my recorder. So now we are going to look at all of these sequences and determine if they're arithmetic, geometric, or neither. So go ahead, and I would recommend pausing the video and looking at these sequences and determining, are they adding or subtracting? If so, they're arithmetic. Are they multiplying? Geometric. And remember, multiplying can also be multiplying by a fraction where it's getting smaller, so it kind of looks like dividing. And then if it's neither of these, then neither. So go ahead and pause it and give it a try. So here we are adding 2 each time. So this one would be arithmetic. This one here, adding 5, 7, so it's not that. Multiplying, no, not by the same, so this one would be neither. And this one, see that it is subtracting 3, so subtracting 3. So this one is also arithmetic. And then this one here, let's see, 3 plus 6, nope, nope, okay. So then multiplying, yeah. So if I multiply each one by 3. So this one is times 3, so it is geometric. This one here, adding, no, because they're all a 1 on top, so that wouldn't be adding. Let's see, yeah, timesing by 1/2 each time. So this is geometric as well. And then here, if we remember from previous, we saw that this is the n squared. So n squared. So that's not multiplying or adding or subtracting, so this is neither. It is a sequence, so just because these two here, this one and this one, are neither, doesn't mean that they're not sequences, it just means they're not arithmetic or geometric. Okay, so now we're going to look at just a couple sequences that are either geometric or arithmetic. And then we're going to write the recursive and explicit formula. So I've gone ahead and written from our notes on the vocab right here. For geometric, we're going to have, if we're writing recursive, we're going to write the first term, and then these stay the same. So we're saying the nth term equals the previous term times the ratio. So again, you can go ahead and start writing this part and then just plug in the ratio as you find it. And then same idea with the explicit, and the same idea with the recursive. So you can see that they're almost the same, but this one's a plus, or sorry, times r, and this one is a plus the common difference. So let's go ahead and get started. So we're going to look at this example here. We have a sequence, and we're going to look for the pattern. So looking at it, I can see that it is adding 2 each time. So since it's adding, it is going to be arithmetic. So we can start by writing what our first term is. So again, right here would be our first term, and that is a 1. And then we're going to take the rest of this recursive and write it down here. So again, we can write a of n equals a of n minus 1. That doesn't change. And then plus the difference, which was 2. So again, we took the first term and wrote it here, and then we wrote the common difference, this here, right here. Okay. So now we're going to go ahead and jump to writing the explicit formula. So we can start with a of n equals the first term, which is 1, plus n minus 1 times the common difference, which is 2. So again, this right here is here, and then this a of 1 and a of 1 go there. Okay, now we aren't done with the explicit formula because we can simplify it. So we can go ahead and distribute the 2. So a of n equals 1 plus 2n minus 2, and then we can go ahead and simplify it even more, because we can do the 1 minus 2. So our explicit formula is 2n, and then 1 minus 2 would be -1, so that would be our end explicit formula. So let's go ahead and jump over to this one here and see what type it is. So adding 4, didn't add 4 this time, so this one is multiplying by 3 each time. So this one is geometric. So we're going to take it and we're going to write the recursive formula first. So we're going to write our first term, which is right here. And so that is 2. And then we're going to write the rest of that where we have the previous term times our common ratio. So our ratio, we want to do a different color because it's not the same as our common difference. It is a ratio is going to go right here, and our ratio is times 3. And I'm going to move that multiplication down a little bit. Okay, so that would be our recursive. And then explicit, we start with a of n again, and then we write our first term, which is 2 times our ratio, and n minus 1 stays there. So again, this is our ratio, and then this is our first term. And then that one is done. We wrote it, we can't simplify it, so that is done. Okay, so here are some try-it problems. I, again, recommend that you pause it and give it a shot, and then watch my explanation of them. Again, I am so missing your guys' interaction and listening to you guys come up with your solutions. And I hope you're staying well. So go ahead and pause, and then go ahead and give these a shot. Okay, so you have taken a chance and tried those try-it problems, so let's go over them real quick. So again, the first thing you're doing is looking for a pattern. So here, looking at it, we are timesing by 1/2, so it is geometric. So then we're just going to plug in our first term for our recursive, which is 1/2, and then our ratio, which is also 1/2 in this case. So again, this a of 1, this a of n, and a of n minus 1, you can just write it down and not worry about it, and then just plug in your first term and your ratio. And then explicit formula, same thing. We have our first term times our ratio to the n minus 1. And here we have a pattern of -3, so it's arithmetic. So our first term goes in on that top line, and then our common difference on the bottom of -3. And then explicit formula, we have our a of n equals our first term, which is 12, plus the n minus 1 in parentheses, that's just part of our formula, times our common difference, which is -3. And then remember, we do have to simplify that, so distributing that -3, which becomes -3n plus 3, because -3 times -1. And then we have to do the 12 plus 3, which gives us 15. Okay, so then this one is also arithmetic. It's adding 2, and we're plugging it in. I hope you guys can see the color coding pretty well. So 1/2, I did yellow for all the first terms again, and then purple for arithmetic common difference, and pink for the ratio. If you're looking at this later on and you have any questions, give Ms. Holstad or I an email, and we will try our best to answer it over email. And if not, we can arrange some other way, like a live video, so that you can see an explanation, and we can do it that way. Again, hope you're staying well. I miss you guys, and I hope these videos are helpful and that they're making sense. Thanks.